Welcome. So, yeah, ops and operability. So, I want to talk about what I believe might have happened. I'm not sure this did happen, but I believe it might have happened. So it's early 1800s, about 1814. Ada Lovelace. Her father's Percy B. Shelley, who's a drug-addled poet. She invents programming. And so Jane Austen, living in the West Country in England, she thinks, well, that's not going to end well. Right, we've got programmers now. So she invents operations. And the way she did it is she had a series of coded books that she wrote in the early 19th century with titles like Ops and Operability. But the editors didn't understand this, so they changed them into, I don't know, the words we know now. So this is my theory, is that Jane Austen actually invented DevOps and operations about 200 years ago. So before we go there, let's just think about this. Imagine a company that treated its customers like this. So thinking about a product company, and it does this. It says there's no consistency in its products. You get one product and you figure out how that product works, and you're feeling quite good about that. And then you get another product and it works completely differently. Like, there's no reason, it just happens to, yeah? So within a product, I've figured out how this thing works. Oh, but now this other aspect of the same product works completely differently. Who's had that frustrating experience when you open two different apps on your phone and they work completely differently and they do similar things? You're thinking, why would someone bother doing that? That's just not fair. When something breaks, I don't mind things breaking. Honestly, I'm okay with things breaking. I'm a software guy. I know that things break. But I want to know, right? So there's no clues when something breaks. It just silently fails, yeah? You don't even know that something has broken. So it might have been broken for a while, right? That thing where, you go to bed and your alarm worked when you went to sleep and you sleep straight through because the alarm didn't go off and you didn't know the alarm was broken until it didn't work. You don't know that things are about to break. There's no clues. There's no kind of warning lights. There's nothing like that, okay? They blame the customer. When it doesn't work, it's your fault. Okay, you're using our product. Our product must be fine because we wrote it. You must be an idiot. Okay? And so they have phrases like provided without warranty. And provided without warranty is this is our product, but there's no warranty. So what does that mean, that phrase, provided without warranty? I don't know, when something breaks, I don't know what happened. These are the sorts of questions I ask. I go, what happened? And I don't get any answers. How can I fix it? Okay, something's gone wrong. I figured out something's gone wrong. How can I fix it? What do I need to do? Can I fix it? Is it even possible for me to fix it? And I'm thinking, okay, well, now I'm feeling a bit helpless, and I'm thinking, well, how long is it going to be broken for? Right? What's going on there? And then I started to get cross. You go through your 7 stages of grieving, right? I've done denial. It can't possibly be broken. And then, I'm getting on to bargaining now. Oh, come on. Right, who can I escalate this to? I'm cross and I want someone to know. And then again, you're just yelling into the void and nothing's happening, right? And so you're just thinking, am I just stuck with this? Yeah? Am I just stuck with this? Does anyone care? Right? So imagine a company that treats their customers. How long is this company going to stay in business? Right? That's not a very successful way to build a company, to build a customer base, to build loyalty. This is how developers treat operations people. All of those things I just said are exactly how developers treat operations people. They get inconsistent things. They don't know when they break. When they break, they don't know how to fix them. When they figure out how to fix thing A over here, it has no bearing on thing B over there. Okay, this is how dev treats ops, and there's a reason for that. Eric Evans, in his wonderful domain-driven design book, he talks about upstream, downstream dependencies. And he says the upstream dependency has the handle, they flush, and the downstream dependency gets whatever comes down the pipe. Okay? And there's an upstream, downstream dependency between dev and ops. So most kind of DevOps initiatives, they start with devs pushing on ops. So DevOps as a movement came about as a natural consequence of agile as a movement. So we had, in the 90s, we had very big, very heavy projects that would release every 18 months, 2 years, whatever, very, very long lead times for releases. And if a release took weeks and weeks and weeks, and it was painful and eye-watering and all that stuff, by the time the next one comes around, you've forgotten that pain. that transaction cost of like several weeks every couple of years, that's kind of acceptable, right? It's a bit crappy, but it's not the biggest problem we've got. What the Agile movement did is it brought that release time down and down and down. So you started releasing once a quarter, right? And that was considered, state of the art. We're going to release every season, whether we need a release or not. Yeah. And then it went down to every month, and then every week. But even if you're releasing every quarter, having very, very high transaction costs in a release is bad. And so that exposes the next constraint, if you like. So the next constraint down the pipe is operations. It's how do we get things into production? So DevOps starts with developers going, well, we've done this work, let's get it into production now. So they're pushing on ops. And ops are like, no one told them, they never got the memo. Yeah, so they're getting a little bit kind of freaked out. And so then you talk to the developers and you're saying, well, why isn't anything in production? They're going, because ops resists. Right? Ops keeps pushing back, they keep resisting. And then you go and talk to ops, and you hear a very different thing. They say, yes, we are resisting. We're resisting efforts to compromise governance, right? Assurance, audit, compliance, control processes, all those things that keep the lights on, all those things that keep us. Of course we're resisting, because you guys haven't thought through this stuff. You've just built some software, thrown it at us, and you expect all this to go away. In this brave new world, then, the problem is this. Ops is still on the hook for a whole bunch of things, right? They're still on the hook for runtime operations. So they've got the support rotor, okay? They're on the hook for SLAs. Once it's in production, I don't have SLAs. I might have some early live support or warranty period or something, right? But after that, your SLAs. Your availability SLAs, your downtime SLAs, your response time SLAs, nothing to do with me on your operations. Diagnosis, understanding when something goes wrong. Right? What went wrong? How do we go and fix it? Yeah. Once I've figured out what's wrong, how do I recover it? How do I make it work again? Getting stuff working again is often the easy bit. Okay. What's happened is while it was broken, there was a period of time where everything got a little bit out of whack. I had data loss. So, catastrophic failures on a database, they're easy. I can see when a database fails. What I can't see is when a database is silently corrupting data, but it looks like it's still limping along. Yeah, I was working at with a large bank a few years ago that will remain unnamed, and they had accidentally been miscalculating how much of the money was theirs and how much of the money was their clients for some years, which is really, really dodgy. It turns out that it was in the client's favor. So luckily, they'd only lost several $1 million, right? Rather than been massively exposed to all kinds of horrible fines, right? They didn't know because it was a really subtle data corruption issue. It wasn't negligence. It wasn't, them being naughty. It was them absolutely not knowing. Restoration is a huge deal, and getting data back on track is a huge deal. And then business continuity, day-to-day operations, making sure the lights stay on. The ops guys are still on the hook for all of these things. Okay, so then, early 1800s, 19th century. So Jane Austen's, very aware of these pressing issues in her daily operations role, and so she writes the first of her famous books, Pride and Packaging. Pride and Packaging opens with one of the most famous sentences in English literature. It is a truth universally acknowledged that a developer in possession of a build must be in want of a server. Okay, so we're trying to get things into production. This is Lizzie Bennett. That's Darcy in the background there, who was a Rails developer, and then he became a React developer, and now he's all about the Elm. Okay, so he's totally hipster. He's got a build. He wants to push it into production. All he's got to do is get past Lizzie. Okay, so we've got a developer. All I'm thinking about is deploying my stuff. Okay, I've got a very tunnel view of the world. So, and this is the first kind of, I think, sort of the tough lesson, if you liked, for delivery people, for developers. Automating deployment is one thing. Automating is actually pretty easy. I was working with a lovely chap, was at the Ordnance Survey. Name's Keith. He's moved on now, but he tells a story. But I did some work with him, and he got really into his DevOps, and he spent some time automating a load of stuff. And I went in there to help out, and I co-authored the build production line paper. So I'm the production line guy. He said, "Oh, Dan, I've got this build pipeline. I've got to show you the thing." So he's got all this DevOps he's done, right? He's done all this automation. And it was a thing of beauty, you know. I spent a lot of time on it. I said, that's fantastic. I said, so what impact has that had? So coining a Goiko's like, what's the business impact of that work? He said, what do you mean? I said, well, let's map out the value stream from the feature's ready to go to the feature is live. Okay, someone's using it. Let's map out that process. And from feature done to feature live was weeks, right? Really quite a long time. And we looked at the amount of time that was, and we said, okay, so what impact has all that automation had? The impact of all that automation brought that down by 45 minutes. Right? 45 minutes on some weeks of work, yeah? But this is why I like Keith. He wasn't like, oh, we're doomed. He said, that's brilliant. He goes, right, now I know what I need to do next. And the next time I saw him, which was only a few weeks later, he'd I don't know, it was less than half the time. Because once you can visualize, once you can see what's there, you can start to see what the impact is. So automating deployment is one thing. Understanding the release process, understanding the path to production is something quite, again. And that's what things like value stream mapping give you, allow you to turn the lights on and see what's going on in your world. But what I want to talk about now is this. Having something worth deploying, that's something else again. Yeah. So it doesn't matter if you understand the process. It doesn't matter if you've got this thing slickly. If what you're deploying, if you don't have something that is deployable, none of this matters. And what I mean by that, I have table stakes for deployment, right? There's a minimum bunch of stuff you need to have in place before I will consider deploying your thing. If any of you were in Goiko's talk earlier talking about serverless and lambdas and all those kind of things, a lot of what I'm going to talk about are things that you get for free when you start using other people's infrastructure. But this is in organizations where we don't have that. So I want to start, there's a couple of patterns I want to talk about today. The first one is it's called phone home. So this is a deployment and operational pattern, if you like. And it's very simple and very powerful. What it says is this. It says any component should have a heartbeat. That's the whole pattern. Okay? If you put anything in a production environment, or really in any environment, it should have a heartbeat. What I mean by a heartbeat is it should send out a message on a regular basis saying, I'm alive, I'm alive. Okay? Because once I can tell you're alive, I can start to do all sorts of other really cool things. You can think of monitoring, I think of it as a 4 or 5 stage process of evolution, if you like. So monitoring starts with instrumentation. So instrumentation says, can the thing I've got tell you about itself? Okay, instrumentation is having the capability to tell you about itself, what it's doing, what's being called, how long is it taking, all those kind of things. Can I produce metrics? The next part is telemetry. So there's no point you measuring stuff unless you tell someone what the numbers are. Okay, so telemetry, which means measuring at a distance, is can I get those numbers to someone who cares? On the back of telemetry, I can now build monitoring. So monitoring is the receiving end of that, is that I can now hear what's going on. After monitoring, which is an active thing, I have to keep on looking at the monitoring. I then get alerting, which is passive. It's fantastic. It tells me. So alerting says, oi, this thing is above a threshold. Okay? And I see that as your 4 stages of monitoring, is you get instrumentation, telemetry, monitoring, alerting, and now Netflix being Netflix, they've then taken that to the next level, which is stage 5 of 4, which is prediction. Okay, so they have machine learning that says we know when we're likely to receive a burst, and we can preemptively spin up enough servers to be able to take that extra capacity. So when you start getting into machine learning, AI based on historical trends in your data, that's pretty cool. But just getting those first 3 is massive, okay? Instrumentation, telemetry, monitoring, that will get you a really long way. So phone home then. Every component should heartbeat. You've got lots of options for heartbeating. My favorite, honestly, is still the simplest, right? Send out a packet. UDP is super easy. UDP, little packet, just send it, broadcast it, okay? Multicast, just send it out to anyone who's listening. You could write to a service registry. I could write to a console or etcd or something. I could just keep on sending messages. The problem with writing to a service registry, if it's a service registry you have to connect to, is it has to be available. And so what you don't want is your little service running and hanging because it's trying to tell people it's alive. That's a little bit ironic. It can send a message, again, as long as you have asynchronous messaging infrastructure. It can send a message. Okay? Any of those things are viable options. The reason I like UDP, a single UDP packet can carry about 1,500 bytes. 1,500 bytes is a heck of a lot of space. Gives you a lot of options. So, surprising amount of information. So, here's an example of a phone home packet. Okay, this is from a real app. Names have been changed, but this is from a real app. And to show you some of the things. So the first thing it has is this, is it has a name. Okay, this component is called product search, and it's part of an app called Online Shop. So I can see immediately what it is and why it exists. And I can do this requires, and here's some other components it requires. Okay, so now what happens is this, as soon as I get that one packet tells me I can now, if I'm now listening for all these packets, I can build dynamically a network dependency model of every single component. Just from that tiny, tiny bit of information. So that means now, if one of these things becomes unavailable, I can tell from its dependencies everyone else that I need to update. I'd say, hey, you guys, you're about to fail because one of your dependencies just went offline. That's a super useful bit of information. Where is it running? Address, right? Heartbeat interval. So there's loads of ways of doing this. This is one of my favorites. The interval, 500 millis. I should expect to get one of these every half a second. What does it mean if I'm getting, instead of every 2 a second, what does it mean if I'm getting 4 a second? What does that tell me? I've got a rogue instance, right? I've got another instance sending these things out, yeah, because they're coming out every half a second. MIA interval, how long does it need to be missing in action before I care? Maybe I'm on a flaky network segment, so it says, do you know what, don't worry if you miss 1 or 2. If you don't hear from me for 5 seconds, assume I've died. And again, you can imagine a monitoring dashboard, and we built a monitoring dashboard off of this. A monitoring dashboard, it sees, as soon as it sees this new thing pop up, up it comes. On a monitoring dashboard, I can see that the product search, a product search node has just emerged. We don't have versions and stuff on here that Goiko was talking about earlier, but that would be trivial to add. So I can see that it's online. If it goes away again, I could color it amber. I could say this thing was here, and I don't know, it's currently unknown status, right? And again, there's a bunch of quite awesome Amazon tools that do this for free, but this is pretty easy stuff to roll yourself, honestly. And then after 5 seconds, I can start telling people stuff that's going on. So what else? Here's some static information. So this is the Git revision deployed from me and when it was deployed. And then here's some dynamic information. So I can see that memory is 80. I don't know what 80 is. I don't know, 80K. I don't know. Right? What I do know is that someone does. Yeah. So it may be that it's 80% of memory is utilized. Right? It may be 80 megs. I don't know. What I do know is that there is a protocol there that the monitoring system is receiving that, and this packet is one of a time series of packets. So I can be watching that number trending. So I can have thresholds around that. Say 80, it might have been 35 on the last heartbeat, and it's now 80, and I've got a threshold of 50. Right? So that's going to trigger something. I can see my CPU load, I/O load, disk, and so on. This is a fun thing. I nicked this from Google. So Google, any service you have running anywhere that has a web interface, you essentially have 2 well-known URLs on it. One of it is all of that static information. So this is a little summary of the static information. /config is all of the static information. Likewise, status is a little summary of the dynamic information. /status is everything you need to know. So now, these URLs, coupled with that address, tells me everything I need to know about there, and the whole thing is now navigable. Right? 1 UDP packet. Yeah? Anyone not doing this on their own systems should be taken out and shot. I know, maybe that's a little harsh. Right? Should be taken out and given a stern talking to, and then shot. So these are the sorts of things that you should be thinking about when you deploy any component into any deployment environment. Make it phone home. The power to weight of phoning home is off the charts. So now let's take a look at that's getting things into production. Let's have a think about support now. So in her follow-up book, Jane Austen wrote a wonderful book called Support and Supportability, which again got sadly renamed by her publishers, but this is the original. Here you have 2 sisters, Eleanor and Marion Dashwood, who are both operations support engineers, and this is them, right? Clearly pissed off, okay? This is our support team. Meet the ops team. That's what they look like every day. That's their going to work ops faces, Okay? And so they say things like this. They say, you build it, you run it. Yeah, that's what they want to say. They say they have no understanding of monitoring. Okay? And this is why they have such sad faces. Yeah? And they say, basically, developers should be on the support rota. Right? That's what they really want to happen. They want developers to be on the support rota. That's not always possible. Where it is possible, you should carry the pager. Okay? So the point here is this. As developers, okay, who have we got in the room who's developers? Who cuts code in this room? Okay, most of you. Any operations people in the room? Excellent. Go and hug those people at the back there. Those guys need love. Okay, you build it, you run it. So empathy is always an option. Putting yourself as developers in the heads of the operations guys and girls is always an option. Okay, what does that mean? Anytime anything happens in production, okay, there's three magic questions. There's only three things. There's three and only three things that matter when you're an operations engineer, when you're on support, and something happens in production. The first thing is this: what happened? Okay, first, what happened? How? If I need an answer to what happened, I need to know who it matters to, because I want to get to them before the failure gets to them. Yeah, I want to be able to figure out who my stakeholders are. And the third thing is, how do we fix it? Okay, and in fact, all three of these are really summed up in one question. The real question is this: how could we reduce the impact of this? And this is something, again, that started in the agile world and then found its way into the DevOps and continuous delivery world, is this obsession with impact. And I think this isn't talked about nearly enough in software circles, if you like. Pre-2000, let's say up to the end of the 90s, and in fact, if you look at any traditional project management or software delivery model, we obsess about likelihood. So I want to minimize the likelihood of a bad thing happening. So I minimize likelihood. I front load all the risk in terms of planning. I front load all the risk in terms of analysis. I front load all the risk in terms of design. Excuse me. So that by the time I get to programming, it's just a typing exercise. And by the time I get to testing, a bunch of highly trained monkeys can do most of it. Obviously, I don't think that, right? But the model is set up to imply that. Okay, we front load all the high risk work so that the lower risk work happens later. And that is a vestigial belief. That is a throwback to our model of software development as civil engineering. Right? If you're building a hospital, you do want to front load all the risk. If you're building a bridge, you do want to front load all the risk, because by the time you've got most of the bridge in place, realizing it's in the wrong place is really expensive. Software doesn't work like that. Okay, we have this wonderful, there's a gorgeous book called The Leprechauns of Software Engineering by a guy called Laurent Bossovet, where he climbs into a bunch of these like received wisdoms about software. And one of them is the exponential cost of change. Right? So I introduce a change in software, in a software system, and as I get towards a release, it exponentially gets more expensive. That is hokum. There is no data. Right? We all believe it, but there is no data. So what the Agile guys said is, not explicitly, but what they did is they flipped the axis. They said, rather than worrying about likelihood, we'll obsess about impact. So if I have a defect, typically what happens, that defect gets all the way into production, someone loses an order, that's bad, right? That costs us money. Whereas if I write tests along with my code, then the impact of a defect is a test fails, right? If I'm building something and James is building something and they kind of both work, but we put them together and they don't work, right? If I have continuous integration, what happens is I break the build. Very low impact. I buy pizza for the team or whatever it is you do when you break the build. Wear a silly hat. That's why I wear a silly hat. I break a lot of builds, right? So we massively minimize the impact. And likewise, in operations, we've mostly obsessed about likelihood, and now we're obsessing about impact. I think it was John Allspore at Etsy. He said, the problem with having 10,000 hours mean time between failure with hard drives is when you have 10,000 hard drives. Right? Now, that doesn't make the likelihood 1, because stats doesn't work like that, but it does mean you have a much, much wider variance, right? It's very likely that some part of your estate is currently out. So now you start designing and architecting differently. You architect for resilience. You architect with the assumption that some unexpected, unpredicted part of your estate, load balancers, database servers, web servers, middleware, is currently unavailable and you don't know which part it is. And so now you change your obsession. You start worrying about MTTR, mean time to recovery, becomes much, much more important than mean time between failure. If you can make mean time to recovery, perceived mean time to recovery, 0, it doesn't matter how often things fail. Right? And this is the Netflix model with the Chaos Monkey. Chaos Monkey is a thing that's running in production all the time, switching things off. It goes around switching off servers all the time, like virtual servers. And the idea is that no one at home is allowed to notice. So what does that mean? That means that there has to be at least 2 or 3 versions of Orange is the New Black streaming into my device so that if I lose one of them, I don't notice. So there's a couple of other bits of infrastructure they have that they don't really talk about that much. There's a thing called Chaos Gorilla. Chaos Gorilla is great fun. Chaos Gorilla doesn't run automatically. It's run manually, and it's run at a weekend. Chaos Gorilla takes out an entire service. Okay? Chaos Gorilla kills all your database servers, kills all of your streaming infrastructure, whatever it is, and no one at home is allowed to notice. What does that mean? That means you need 2 entire sets of infrastructure running, streaming stuff to my device. Okay? It gets better. They have a thing called Chaos Kong. Chaos Kong, they run about once a quarter. They take out an entire data center. Okay, we're going to kill US West 1. Okay, rule? No one's allowed to notice. So that means not only have I got resilience locally and resilience across things, I've got resilience across data centers coming into my device so that I don't notice. They've designed that in so perceived downtime, even if they have a catastrophic failure, is no one notices. I can't help asking myself the question, but you're streaming video. Like, I would love to see that amount of care and attention applied to things like finance systems, healthcare systems, safety critical systems. That would be cool. But these guys are at least paving the way. So this is my logging question. I always ask this logging question. So what's the difference between logging a warning and logging an error? How do you decide whether to log at an operations guys? You're excluded from this. Developers, if you're going to log something at a warning level or an error level, how do you make that decision? Am I happy to be woken up with the warning? Imagine being paged at 4 a.m. for your error message is how you make that decision. Because you won't be. He will be. And he's got kids, and his kids are crying, and they just went to sleep at 3 a.m. Okay? And so this is what's happening, right? We developers have a duty of care to think about the impact of those error messages. Okay, so then, here's another pattern I'd like to share with you. This may end up being quite a short talk. It's usually quite a long talk, but I seem to be barreling through it today, so we might have time for a bunch of questions at the end. So, Captain's log, then, is a pattern. So it starts with this. It starts with I'm pairing with a guy, another developer. It's a few years ago now, and he taught me a lot of stuff. And one of the things he taught me was this. He came and sat next to me. He said, "Oh, what are you working on?" I said, "Oh, come and show you. I'll show you what I'm doing." He said, "No, don't tell me. Let me work it out." I said, "What do you mean?" He said, "So." He tried to run it, and it didn't even compile. I said, "No, I'm still coding it." He said, "Okay." But I can see from the compile errors what's wrong with it, so got it compiling, and then ran it. And he said, "Okay." So I started explaining to him what it's doing. He said, "No, let me figure it out." So he runs it, and of course, then he couldn't figure out what was going on. And I learned something really important that day. I learned that someone who isn't me should be able to figure out what my thing's doing if I'm not there. And that should be true all the way through development. And that got me thinking quite strongly about log-driven development. Well, not log-driven development, but at any point, you should, any failure in a system, even if it's a thing you're still writing, should be self-describing. It should tell you what's going on. So here's what I think a good log message should contain. Okay, so the first thing a good log message should contain is this. It should contain 2 kinds of timestamp. Okay, it needs to contain a timestamp for human beings. Okay, so I need to be able to look at it and see what was going on. I also want a timestamp for machines. I want a machine-readable timestamp so that I can grep, so that I can sort. And both of those timestamps are important. If you don't have those things, it's not a log message. It should have a unique correlation ID. So there's a Google published a paper about a system they had called DAPA. And DAPA is a spanning protocol. So what that means is you can track all of the behavior, all of the interactions of a distributed system from edge to edge in one of these things called a span. And what happens is the first time something hits the edge of your system, it's given a unique ID, a UID, and that lives with it all the way through. Now that can fork, and every time a fork happens, you get these sub-UIDs, and when they come back together again, it can make sense of them. They have very highly accurate GPS clocks in all of their nodes so that they can get pretty high precision. And what that means is they can figure out what went wrong. Okay, they use this on a sampling basis because it's expensive to do that for every single call. But so at some percentage of calls, they'll sample them, and then they capture all this stuff. And again, so that's your instrumentation, telemetry. It gets sent somewhere, and then they have a system that can make sense of this. Twitter open sourced a system called Zipkin a few years ago, and Zipkin speaks DAPA. So again, it's something that takes samples of flows through your system. And it allows you to understand exactly what's going on in there. So I want a unique correlation ID. I don't want to have to guess where messages came from. I should be able to figure out the source of everything that goes on in my system and trace it back right to the very edge to some external user-initiated or system-initiated inbound event that caused a whole flurry of activity. It's also super useful for finding things like emergent behavior, like cascading failures, where you get sort of feedback in the system that starts to cause out-of-control behavior and multiplication of messages. So I want a unique correlation ID. The next thing is this, is I want to understand, and this is a nod to Ted Codd, the guy who invented the relational database, the cause, the whole cause, and nothing but the cause. I want to know what went wrong. I want in that log message to know everything that went wrong. I don't want to be looking around trying to piece things together at 4 in the morning when the page has gone off and my kid went to sleep an hour ago. Okay, that is the mindset you need to be in. Is I'm not at my best. I'm bleary-eyed. I'm a little bit unfocused. This just happened, and I'm not you, and I don't have access to you, and I won't have access to you for another 8 hours because I'm in a different time zone. Okay, so I need to know what went wrong. I need to know all of what went wrong. And no noise. Yeah, so things should. I love the idea of things should succeed silently and fail noisily. Right? When they fail, I want to know everything I need to know, but no extraneous stuff. And finally, the log message should give me the answer to my 3 questions. Okay, or at least give me clues to those 3 questions. What went wrong? Who's impacted? How do I fix it? If I can understand those 3 things, I can recover very, very quickly. And I guess the takeaway from this is that a log, any monitoring system, is an append-only, read-only user interface. Okay? We should apply the same design aesthetics to a log file, to log messages, to monitoring, as we do to any other user interface design. Okay? It should be consistent. It should have affordances. It should be easy to understand what's going on. My eye should be drawn to the important stuff. I shouldn't be distracted by the noisy stuff. And it should be, if I look in one place and I see a message, I should be able to look in a different place and see a similar message. So then, ops and operability. This brings us kind of full circle. Ops and operability is really use and usability. And this is the thing, as developers, when we're building systems to run in an operating environment, in a production environment, we need to think about that operating environment as a user experience where the users are operations people and support people. Okay? And just as much care should go into what is supportability, what it means to use that system, as we would put into any other aspect of designing that system. And then we end up with happy ops, which is fab. Because look, they're smiling now. Why are they smiling? They say things like this. They say, developers study how we work. Right? They bother coming down to the machine room. Yeah, when we were working when I was working on the team with Jez Humble in the mid-2000s, where we were building out the automated deployment scripts. We were discussing what language, what technology we were going to use for the automated deployment scripts. And we said, oh, it's Ruby, Python, blah. Then we said, why don't we go and ask the ops guy, Phil, the ops guy. And we went and asked Phil, and we said, Phil, if we're going to write these automated deployment scripts, and then we're going to leave, and you're going to end up with them. So what do you want us to write them in? And he said, Bash. And we went, oh. Right? It's okay. I don't mind programming in Bash. I've programmed in all kinds of shells. But so we did. We wrote the whole of this deployment. It was called Conan the Deployer, which I was quite pleased with. So we wrote the whole of this deployment suite in Bash. To be fair, I still tell this story, and he hit me up on Twitter recently, and he said, by the way, if you ask me again, I'd say Python. I was like, yes. Right? But so we did. We went and studied how Phil works. And what Phil would do is he'd come in on a weekend, because that's when you had to do releases. You did releases at the weekend when there were fewer customers online. And what happened was we gave him an automated deployment suite, and that meant that the 8 hours of deployment was now a 25-minute fully automated process with like a sub-second cutover on Apache. And that meant that he could do that same release on a Monday morning. And so that meant we gave him his weekends back. Okay, and we only knew this because we went and hung out with Phil. We spent time with him. They learn about release engineering. James Lewis was talking about SRE earlier on, site reliability engineering. Okay, there's two models. I think there's two models of of successful models of having decent release engineering. One is you make the whole thing completely self-serve, yeah, and the other is that you raise the skill and ability within the team that the team is fully autonomous. And it kind of is up to you where on that scale you want to be. But I think unless you go after one of those two, you're always going to be in a situation where, again, the need to release leaves the team, which means the team's now hanging on a ticket not being processed or whatever, and then they wait and it comes back. Yeah, so anything that means that either they have autonomy because the whole process is self-serve, or they have autonomy because they have the skills and capabilities and the authority within the team, I think those are the only ways, really, you can have sustainable release engineering. They look beyond their own apps. Okay, so we're not looking at like all these teams are autonomous, which is fab, right up until they have 17 different database technologies across 17 different teams, and each team is like, oh, I've got Cassandra, I've got Redis, I've got Mongo, I've got whatever else, and then which is great if you're that team. If you're the downstream operations guys, that's now 17 different technologies you have to install, manage, patch, secure, upgrade, okay, learn. Right? And that's just databases. That's just stores. What about all the other kind of technologies? So as a development team, we understand what the broader implications are of technology choices we make. They learn about security. How many people in this room understand the security implications of the software they're building? One security guy at the back. I build security systems. I know what I'm talking about. I'm giving a talk about security. Okay, yeah. You get a pass. Most of us build desperately non-secure systems. Yeah? I'm a bit of a security nerd, and I'm rubbish at security. I know just enough about security to know that I'm rubbish at it. So I try and hang around security people, and then I check my phone afterwards. Right? They learn about security. They're devs thinking like ops, yeah, which is kind of cool. Maybe there should be a word for that. Okay, so that's basically all I had to say. So, which I think means I've come in record time, which is really unusual for me. So that means we've got plenty of time for questions and hanging out. Or if you want to get a coffee, you can get a coffee. So thank you.
Logs are a user interface, but there are multiple different users for logs. So there are the ops people who go, well, what's happening there and what's going on? You have back traces for developers. You have application support people who want to go, what's going on here? I want audit trails, non-repudiation, all that kind of stuff. So actually, I think you may need more than one log.
Well, so this is it. So I see logging is it's a great observation. Logging is a specific case of monitoring. That's what I think it is. So, and with any kind of monitoring, it's about who's the audience. So I might want, as you say, non-repudiation and audit as a type of traceability. I might want developer stack traces or back tracing as a kind of traceability. I might want recovery as a kind of traceability. But again, all of this is still UX. It's still usability. So everything in that log and everything in your logging world, if you like, isn't, I'm just going to dump this out into the log. It needs to be, and if you're going to have multiple audiences served from the same log file or from the same source, the same monitoring system, then tagging is really vital. So you can say, tag this message. This is going to be useful for this, and this audiences. And so I can look through for the kind of audience, the stuff that's useful to me. So yeah, thanks for that. Any other questions, thoughts? Right next to you, that's handy.
Yeah, for the phone home pattern, are there any particular schemas, kind of industry standards that you recommend using?
I don't know. It's a good question. I'm sure there are. As with any standards, not any, certainly an awful lot of standards, I find that they are a lowest common denominator. So that particular one started as I'm alive, right? Just literally I'm alive, and then we evolved it into those things. So that, to me, that's sort of pretty good table stakes, right? What are you? Who do you belong to? What are your dependencies? Some static information, some dynamic information, and then how do I find out more? So, for instance, there's no reason not to use an Atom feed for that. You know, so I could have refs in there, and the refs would be to various different other resources that would give you your kind of your discoverability. So I would lean on standards where they're there. Honestly, though, the ones I've built, we just kind of figured out as we went. But so things like using Dapper spans probably would be a good thing to do now. Any other questions, thoughts, observations? Yeah. Oh, little cluster of people over there that were listening and care. Thank you.
It's more a specific question around like ASP.NET. So you have the.
I might need to ask a friend then. But go on. Yes.
Yeah. So for logging, you have middleware that you could use that just does logging based on request and response.
Yeah.
Is that sufficient, or would you actually do logging pretty much everywhere in your code base?
Right. I can answer this. No, it's not. Not even close. Yeah. So what that does is it tells you request response. What it doesn't do is things like it doesn't tell you why, and because HTTP, once the conversation's finished, is effectively stateless, it means that if there's a whole bunch of these things that are related, I can't correlate them. So I need some other thing as well. So either it needs to be something that's carried in each request, or I prefer it to be. So there's a lovely pattern from REST called reifying operations. So, for instance, what we used to do was we'd have, a bunch of places still do, we'd have, say I'm applying for a loan online. I would have some session state, and in that session state I would have a loan object that I'm gradually populating as I go from screen to screen through my wizard. And eventually there's a submit button, and the submit button says, validation, and then it sends off my loan. And that's how we used to sort of build those systems. Reifying an operation says take the operation and turn that into a thing. So reify comes from res, Latin res, which means thingify. So, so if I'm applying for an application, that's the verb. So flip that into a noun, and it's an application. So I have a thing that's a loan application that represents these screens I'm going through. And the loan application has all the same fields as the loan object, if you like, but each of those also has a bunch of metadata in them. And this thing can be as messy as you like. So this thing is going to have a load of validation around it. But say the loan form, I need to know about you, I need to know about the amount you want, I need to know about your credit history. Right? There's 3 things I need to know. And so as you're going through these, it's not really wizard screens anymore, it's just a big form you need to fill in. Each time you change anything, I update the loan application data structure with the new value and when it was set, a bunch of metadata about it. So I can see exactly, as I go through, essentially what I've done is I've serialized that session state. So what that means, I'm doing a James ramble now, what that means is at any point, if you go away, I can see exactly how far you've got in that thing, and when you come back, I can reconnect you to it. But it also means across many, many people, I can see when people drop off my form. I can see when they get bored and go away. So if you think in terms of reifying operations and you capture every single interaction that goes to building up a query as well as the query itself, and then that flips into the query itself, that's a really powerful pattern for being able to understand what the actions were leading up to something. It's probably a longer answer you're expecting.
Yeah, I mean, so I've heard if you put logging everywhere, it kind of dirties your classes in terms of another thing. So you just have to be unapologetic about it. If you have to log somewhere, just log.
So again, I think of logging as a specific case of monitoring. So what I will do is I will inject a monitoring object into things. Yeah. So monitoring is just another service. So as my application is running, it's sending information out to a monitor, and that monitor can be doing whatever it needs to be doing. So that makes it very explicit the things I care about, because those things I care about are being monitored. A kind of logical conclusion of that is when you get into what's called event sourcing systems. So event sourcing systems, everything that's interesting is turned into an event. So I have these event objects, event data structures, if you like, flying around the place, saying someone is logging in, someone has logged in, or someone is attempting to log in, someone just failed to log in. So all these events happen, and I can keep an event stream of all the things that happened, and I can replay that stream, and I can see exactly what I can recreate the world at any point in time. So that needs to be a fairly fundamental architectural decision you make to set out with an event sourcing system, so that essentially your logging is almost for free, because your logging is that event, the transaction log over all those events. So that's a much richer way of doing that kind of monitoring. Any more for any more? Hand in the middle. Oh, hang on. There's a microphone hurtling towards you as we speak.
Ignoring the event sourcing thing that you just said.
Okay.
No,
we were never here. There was no event sourcing.
I know the answer to that one already, but if you're just doing regular, normal file-based logging, do you tend to test that, unit tests or whatever, or is it enough just to kind of sprinkle it where you think you need it, and that's good enough?
That's a really good question. I don't think, I'm going to be completely honest, I'm sure I can come up with something, but no, I don't think I unit test logging. What I do is destruction test logging. I stress test logging. So I will cause things to break to see whether someone else can figure out what happened. So like I said, I learned that lesson quite deeply pairing with this guy. It was just one of those life moments where you go, wait a minute, I see what you're doing here. He said, right, don't tell me what's going on. I'm going to see if I can figure it out from the information that's there. And so I could write tests, but those tests carry my confirmation bias. Here's what I think you should be able to see there. Whereas if instead I say, hey, James, come over here. I'm just going to pull the plug out on this thing. You tell me what you think is going on there. And if he sits there scratching his head, I've got logging wrong. And I think that's a much more robust form of verification of that. Because there's a verification and validation thing. There's like, does it do what you meant it to do? And does it do what it should be doing? Are often two very different questions. And we're really, really good at testing does it do what I meant it to do? And what we tend not to do is square the circle and say, is this actually useful? And unfortunately, it's like there is no backup strategy. There's only recovery strategy, right? You don't test your backups, you test your recovery. Yeah, and if your recovery works, your backups are fine. Yeah, and it's the same sort of thing. It's like you don't test logging. You test diagnosis, you test recovery. And if those things are working, you've probably got logging about right. It'd be interesting to think about how you do automation of that. Cool. Any more for any more? Well, thank you very much indeed, and enjoy the rest of your NDC.